Okay, so last week I think we finished the transmission and everything. So today is transmission and the drivetrain, complete drivetrain we finished last week. So today what we're going to discuss is the steering and the wheels of the vehicle. So my plan was to actually combine the suspension also into this, but it seems like too big. The class is going to be too long, so it will be boring. So therefore, I'm not going to discuss the. I'm not going to discuss that part today. Okay, so we'll go ahead and see what we're going to discuss. Okay, so basically we'll be discussing about the functions of the steering system, the type of steering sensitivity, and the wheels. So how these wheels and what sort of wheels are available. Okay, so yeah, the image should be changed. Okay, so we'll start with the steering. So steering, as you know, the steering system is mainly used to actually guide the vehicle into the direction that the driver want to actually travel, right? The driver want to actually travel. But even though it seems simple that whenever we turn the wheel, the whole vehicle is traveling in that direction, it's not exactly that simple. So vehicles, the steering is supposed to have a specific geometry or specific characteristics it should actually have in order for the rear wheels to actually follow the front wheels, right? So the basic part, the basic idea of this is both both axles will be following the same line. That's the main requirement of this steering system, right? The steering and the alignment and everything has to be work, alignment, steering and suspension. So like steering, suspension, wheels and everything actually has to work very well in order for steering system to work, right? So we'll start about the steering system. I know you have already discussed about the steering system, how this what you call this power steering system and the brake and pinion steering system. There are those things you already discussed in your practical, but I'm going to discuss something else. So the theory behind this steering system. Okay, so basically I expect that all of you guys can see these images, right? Wait. All right, so if you look at the first image, right? If you look at the first image is actually a horse carriage, right? It's the horse carriage. So you can actually see the horse carriage. One important thing of a horse carriage is this steering system. So it's very different from the steering systems that we used in a normal automobile. So basically the automobiles are derived from the horse carriages, but the steering system is completely different. So you can see here there's a center pivot point here, right? Center pivot point or a center point where the whole axle is actually rotating. Instead of just the two wheels on the either sides of the axle, the whole axle is rotating in these carriages. That's how the early steering systems were, right? That's how the early steering systems were. The reason for this is it's actually very simple. So if we like, right, let me try to okay, so what I wanted to actually discuss is, now assume a tractor or any vehicle is actually coming from this way and it's take a turn and goes out from this way or comes out from that way. So in order for this to happen, right, we discuss about the differential. In the differential, we discussed that the inner wheels have to actually travel in a short distance and the outer wheels actually have to travel on a longer distance for differential. And the same thing is actually happening in the front axle also. But front axle, in order for these two vehicles to these two axle, or in order for a vehicle to travel, now if we look at the front axle, right, if I try to draw the front axle wheels from the top, right, I'm going to draw the wheels from the top, right? I'll use the highlighter. So one wheel actually have to go this like that, and the other wheel actually have to go like this, right? Button, right? But the vehicle, if we consider about the axis, the vehicle can't actually do that. Vehicle can't actually do that unless we have the axle like this, right? So axle like this means the vehicle actually have to have a pivot point in the middle, right? Pivot point in the middle. Now, if we go back to our first image, so you can see there's an axis on the middle. So the pivot point is in the middle. So the front axis can turn around it, and there are two. So with that, the outside wheel of this turn, now it's actually taking a turn. Outside wheel can actually rotate the further distance, and the inner wheel can actually travel a shorter distance. So that's how these these horse carriages were actually built. But unfortunately, that was not a solution for a vehicle, because the reason is, for these they actually had something like a horse. So wherever the horse goes, the vehicle has to travel. So having this system is useful, but in order for a vehicle to have this is too cumbersome, or it actually takes too much of space and difficult to handle the vehicle. So vehicles can't actually have this particular application, but still it also need to travel on the same it also have to travel on the same path. So what everyone, or the designers or the developers actually came up with is something like this. So you have one wheel like this, the other wheel similar to that. So one wheel is actually turning bit more than the other one. So the diagram is not exactly correct. So there's one actually has a larger radius wheel, so that wheel is turning a little bit less than the other one. So that's what actually these vehicles actually use, right? Sorry, right? So this system, this sort of center pivoting point system could not be used for the vehicles. So a different system needed for vehicles. So that's what actually we came up with. So this image actually showing very well what I was actually explaining. So here you can see, right? You can see the vehicle is trying to take a turn, and when the vehicle is taking the turn, if we draw a center line, right? So each wheel actually have to follow these two radiuses, these two radiuses which are shown. Wait, I don't think you guys can see my cursor. So this is the outer radius and this is the inner radius. So in order for the vehicle to actually travel on this path, the outer radius and inner radius curves have to be matched by the inner and outer front wheels. So in order to achieve that, the front wheel actually have to turn 26.60, sorry, outside wheel actually have to turn around 26.6 degrees at this instant, and the inner wheel actually have to turn 36.2 degrees. But when it is doing this, it's actually does not have any center point pivoting. Instead of, it's actually pivots around these 2 points. These are actually known as steering spindles, right? These are known as the steering. There are few names. This the point where the steering actually turns, that part is actually known as the steering knuckle. Steering knuckle, right? So this section is known as the steering. So the steering knuckle is responsible for this steering. So this particular system, right? This particular system is actually known as Ackermann steering. Okay, Ackermann steering. So Ackermann came up with this system. That's why it's actually known as Ackermann steering. So it's a very simple system, right? Very simple system. What he suggested is, right? So front wheels and rear wheels, right? Front wheels and rear wheels are like this. So for any vehicle, the the distance between the left and right wheels, right? Left and right wheels of any axis is actually known as the track, wheel track. So the distance between the front and rear wheels are known as the wheel base. Okay, so front and rear is the wheel base, and the left and right, the axis between the distance between the left and right axis wheels on a one single axis is known as the wheel track. Okay, so the vehicles can have different wheel tracks on the front and rear. That's depends, right? It depends on the design and what are the requirements and all. So what this Ackerman actually found out was, if we can, so this point, right? This is the pivot point. So this is your front axle. In the front axle, you have two pivot points for each wheel. So each wheel has one pivot point. So there are two pivot points which are dedicated for each wheel, left and right wheels. So if we link them, right? If we link them in a way to create a parallelogram, right? Parallelogram means this one. This is the parallelogram, right? This shape is the parallelogram. And if we make a parallelogram where the either sides actually comes and meet on the center of the rear axis, right? Center of the rear axle, at all times, this particular system can take a turn without any trouble. So when we manage to fix the steering system into this particular arrangement, that's the Ackerman steering geometry, right? Or Ackerman geometry. So when we fix it to the Ackerman geometry, the both wheels, right, as shown in the second image, both wheels are actually turning on a one center line, right? And the center line that goes to the rear axle will also, the center line that goes through the rear axle will also go through this single point, and this single point becomes the turning point for the vehicle. So the vehicle is always going around this point, right? That's what actually meant by Ackerman steering, right? So Ackerman steering is not that so this is actually known as the true Ackerman steering, right? True Ackerman steering, but there are variations of the Ackerman steering. So Ackerman steering is actually comes in a very simple equation. So as shown here, the Ackerman steering is equal to cot theta I1, theta I minus cot theta O. That means input inside wheel. So this is the theta I, and this is the theta O. So outside wheel and inside wheel, right? So this angle is actually, we call it as the steering angle, right? So this is the steering angle, and then it's equal to minus d over L. So here d means the distance between the two wheels, so wheel track, right? Wheel track. And L means, right? L means the distance between the front and rear axles. So that's the wheel base, right? Wheel base. So this equation you guys have to remember, right? This equation you have to remember. We'll do few calculations, like a small tutorial we'll do, so you guys can be familiar. You guys can be more familiar with the module. Sorry, this equation. So yeah, so until then you guys just have to remember the equation, right? Don't have to find or to try to derive or anything. You don't have to do that. Just remember the equation. That's more than enough. This is the simplest form of this Ackerman geometry, right? This is the simplest form of this Ackerman geometry. So we'll discuss about this Ackerman geometry bit more, like how this is going to affect the steering performance and everything. But before we go there, we come back to the our normal day-to-day steering system. So we know there are like two different steering systems are there, right? One is manual steering system, other one is power steering system or power assisted steering system. So manual steering system is the pitman arm steering and rack and pinion steering, which you already have discussed and learned so many times in your A levels and in the university, like in the practicals. And the power steering system, rack and pinion power steering system, and electric power steering system. Okay, so I know that we have discussed this rack and pinion hydraulic power steering system, but so I'm not actually going to discuss this again and again. It just does not make any sense to just waste the time on the same thing, right? So these things we can discuss bit further in the suspension also. So now we come back to here. Now here, right? You guys can see this part. So this is where the parallelogram part is actually created. This is where the parallelogram part is actually created. So this angle, right? I will show you. I will show you some photos when it comes to the suspension system. When the front suspension system, I don't know whether we have any photos here. In the front suspension, if you look at them carefully, one single component is there called as the steering knuckle. So in the steering knuckle, this part is there. The steer wheel and everything is connected to the steering knuckle. Okay. Yeah, I added few videos. You please go ahead and watch them. If you are not that much clear with these things, unless we do like a practical, it will be quite difficult to actually explain in this way. Anyway, so rack and pinion power steering system. I'm not actually going to discuss more and more about the hydraulic steering system, but instead of that, I'll directly move into the electric power steering system. The reason I'm more interested in discussing about the electric power steering system is that electric power steering system is the one that being the norm now. So almost every vehicle is actually now having a electric power steering system. So electric power steering system is very simple, right? Very simple. If we draw like a diagram, in the like most complicated type, the steering system is somewhat like this. Okay, somewhat like this. So you have the steering wheel, right? You actually have your connection with the vehicle through the steering wheel. Then steering wheel have a direct steering shaft that comes to the rack and pinion steering. So you have the rack and pinion. So still you have the direct connection, right? You have a direct physical connection. In the steering wheel, right? Sorry, in the steering shaft, there's a small sensor. We call it as a torque sensor. Torque sensor measures how much of torsional force you have to actually put in order to rotate, right? In order to rotate, right? Then we have another geared wheel attached to this shaft. Mostly it could be to the shaft or this companion part also, that can be do somewhere. There's a wheel connected. So your input for this electronic power steering system, there's a small control module, right? Small control module. That control module actually actually it communicate with the whole vehicle, like everything that we discuss about this powertrain control module. So that controls the vehicle speed, the gear ranging, and everything is actually uh, communicated to this steering system's electronic control unit, right? Then that electronic control module understands or do a small calculation, not actually calculation, it also have some data included in this ECU. Then based on that, it decide how much of force has to be given as the assistant, right? As an assistant, right? So that force is actually given to you through this worm gear. So it's like so when you are trying to turn, there's another person who's actually turning your steering. That sort of thing is actually happening here, right? But that person, instead of having a person, there's a electric motor, right? There's an electric motor which is actually uh, geared to your steering shaft. Okay, so this pinion, right? This pinion Then this pinion and rack and everything is as usual. There's no different. The same vehicle. So if you have a rack and pinion steering vehicle, without any trouble, right? Without any trouble, the power steering conversion can be done. But there will be some difficulty in some vehicles, some steering systems, because some actually need these ignition vehicle speed, engine speed, these sort of details, right? The reason for having these details is uh, to fine tune the steering, your steering input, right, or the steering output. The Even though I don't know whether you guys know about this, the steering is a very important aspect of a vehicle, because there's a communication between the driver and the front wheels, gives an idea for a driver. A well trained driver can actually understand how fast he can go, and everything is actually communicated to this steering, because that's the physical connection, right? So that physical connection needs to be very precise, right? It should be very precise. So when the vehicle is going at faster speed or in a higher speed, the amount of force, the supporting force, should be actually less. You don't need that much of a force. But so for these reasons, to reduce and increase the force as needed, only we have this vehicle speed, engine speed, and ignition speed control modules. Okay. So those things also fit into the ECU. The torque sensor gives how much of torque the driver put, and decide how much of support the motor has to give, and that is actually transmitted to this rack and pinion system. Okay. So the more of like a more actual version, or a more realistic version, is actually shown here. So everything, the all the components of the steering system is actually, power steering system is located here. So it's very small, right? It's very small. So there's not like there's a pump in somewhere, hydraulic lines are coming from another place. That sort of complexity is not here, right? That sort of a complexity is not here. So these are very popular now, right? These are very popular now. So one of the main reason for this is it's actually cost effective, right? It's very cost effective. There's no need to add another pump or anything. Just add the single section for the vehicle. So this is the only section needed to be added instead of the conventional steering system. So any vehicle can be run with this. Light weight, as there's no heavy hydraulic pumps. So there's no pumps, no hydraulic lines, there's no fluids involved. So very less weight. There's only one motor and a simple set of electronics, right? And fuel efficient. This is very fuel efficient, because there's no pump driven by the engine. So there's nothing to actually rob take some of the engine power. And maintenance free. No hydraulic fluids or anything needed here, right? And easily can be adapted with the drive-by-wire technology necessary for advanced driving assistance. Now, this is an important part, right? This is an important part. The importance of this is, now I think you might have seen that steering modern vehicles, like very modern, sort of like a vessel, or what do you call this, any new vehicle actually have like lane keep assistance and cruise control with lane change assistance, and even this what do you call this, mm, self-driving vehicles, and all of these things, right? All of these things actually need a way to control the vehicle's direction, right? Vehicle's direction. So that part can be only achieved by using this electric power steering, right? EPS. There's no way to control the hydraulic power steering, because it's completely a mechanical system. But here, right here, if you come back, right? If we come back, so this ECU, right? Even though we are turning the steering, right? If we are turning the steering, let's assume, right? Okay, not that. Let's assume that there's no connection between the torque sensor right? Torque sensor and this worm gear, right? There's no physical connection between the steering and the rack and pinion. So at that instant, right, at that instant, ECU have the whole control of the vehicle. So based on the steering input from the torque sensor, the ECU controls the motor, right? The same thing, it works as it works fine. It works fine. There's no problem, anything, right? And there's added advantage. Added advantage is you can actually give a additional input, right? Additional input in like something like a cruise control. So the steering wheel, assume that the vehicle is now in automated drive version. So you have the steering column and you can turn, let's say you want to turn to, if you want to change the lane, you're going on a highway, you want to change the lane. So you have your uh, turn signal stop. So you turn on the left turn signal. So when you turn on the left turn signal, vehicle identifies, okay, you want to change the lane. So in order to turn the lane, you don't have to actually touch the steering. The ECU, the vehicle control module, send a signal to the ECU, you need to go this much of to that side. So based on that, steering system do everything, right? Steering system does everything based on that. So the system becomes very simple. The system becomes very simple. Yeah. So that's what actually need that. That's why these systems are becoming very popular. So drive-by-wire systems can be achieved very easily. So for now, modern vehicles actually have this lane keep assistance and everything. Even though if you try to turn it to the let's say you are trying to take it to the vehicle is trying to go to the other side, then at the instant the servo motor can take over and it will turn back you into the correct lane. That sort of things can be done by this. So for and there's one thing is reverse or parking assistant. So in order for parking assistant to work, the main part is this section. So parking assistant, the whole system actually controls the steering section, nothing else. So park assistance, the brakes and the accelerator is controlled by the driver itself, right? But steering is controlled by the vehicle itself, right? Modern there are even higher advanced version where the vehicle can control everything, but the basic system is that. So in such a vehicle, there's no need to actually for vehicles to have any additional components. Just by doing a software update, the vehicle can become a one with the reverse, sorry, parking assistant, right? And so what are the disadvantages? So the main disadvantage is actually the less feedback, right? Less feedback because of this motor takes over most of the time. It's actually reduces the feedback towards the driver. So that's a big issue, unfortunately. Okay, so yeah, so this is now I can actually show you the steering knuckle, right? Steering knuckle. So this section over here, right? This whole section, this is a cast part, right? Cast aluminum or cast steel or something like that. So this part is actually known as the steering knuckle, right? Steering knuckle. From this steering knuckle, there's another sort of like a shaft coming outward. This is the spindle. This section, the one actually coming out is the spindle. This is where we put the spring bearings, right? This is where we put the bearings and we put the bearings and all. So now we have the vehicle in this way, right? So when we turn, right? When we turn, actually this tie rod actually move left and right, turn in the vehicle. So this is for the MacPherson strut, right? This is a MacPherson strut suspension system, and the one above is actually known as a double wishbone arm steering system. So all of these steering systems are using the same, all of these suspension systems are actually using the same method, but there will be small differences in the components. See over here, the knuckle is as usual. So knuckle is here, right? This, sorry, knuckle is as usual, but the knuckle, the shape and everything is somewhat different. You can say there's like a C-shaped component, right? Then the suspension arms or the hydraulics, sorry, struts are coming and connected to the knuckle over here instead of the knuckle coming and sorry, suspension, sorry, coil spring coming and the strut is coming and connected to the knuckle directly itself, right? So there are small differences in these, but these things comes because of the vehicle, how the suspension is going to react, right? We'll discuss about this one bit further, suspension part. Okay, now we come back to this Ackerman part. So Ackerman, there's like even though we have this Ackerman system, there's like more, less, and true Ackerman sort of, right? Ackerman is just a way to actually identify this. It doesn't mean that every vehicle is actually following the same Ackerman principle, right? Some vehicles are actually following more Ackerman principle. Some vehicles are following less Ackerman principle. So true Ackerman principle means when we actually connected these parallelograms, they comes and connect or intersect in the center of the rear axle, right? That's the number one. That's called as a true Ackerman, right? More Ackerman angle means, right? More Ackerman angle means the these two lines, that steering knuckle connections actually comes, and we extended these lines and they coming and connecting before the rear axle, the center point of the rear axle. So these are intersecting before the rear axle, right? This is actually known as the uh, more Ackerman angle, right? More Ackerman angle. Then the other one, if it is beyond or behind the rear axle, it's actually known as less Ackerman angle. So based on what sort of Ackerman angle is actually the vehicle is following, right? The steering, the performance of the vehicle is changed. But based on the vehicle, how it's designed and everything, these actually has to be decided from the beginning. So the designer has to actually decide on this. But one thing you have to understand is when this Ackerman angle is actually changing, toe in and toe out is changing, right? What's toe in and toe out? We'll discuss, right? Toe in and toe out is actually changed, right? So when this toe in and toe out is actually changing, there's another thing coming up. The steering sensitivity is also going to change. So what is steering sensitivity? Now, steering sensitivity means how vehicle's steering is actually going to act. That's what I mean by the steering sensitivity. So we have something called oversteer and understeer, right? So if we look at the front, the first image, it's actually called as oversteer. So vehicle is supposed to go on the green line, right? Vehicle is supposed to go on the green line, but because vehicle is turning more than it's supposed to, the steering, by turning the steering, even though we expect the vehicle to go in a single direction, it actually goes more than that, right? It's turned more than that. So this is actually known as a oversteering, right? And if it is turning less than that, it's actually called as understeering, right? I think you might have heard this, the vehicle is understeering, oh, now it's oversteer, this and that, right? If it is not moving, or if it is actually following this green path, right, or the path it's supposed to follow, that's actually called as neutral steering, right? So this steering sensitivity is very important, right? Steering sensitivity is very important. For some applications, oversteering is good, right? Some applications, oversteering is actually very good. Some applications, understeering is very good, right? So oversteer, in such cases, the oversteering is actually very good for vehicles like racing sort of vehicle, right? Racing sort of vehicles, it's good to have the oversteering. But for a vehicle Because when we oversteer, the vehicle ended up actually turning too much and sliding the rear, right? So riding this, sliding the rear is good for good for racing, so it makes it easier to control. But in a normal day-to-day life, right, this oversteering is a difficulty, because if we try to oversteer and if we go too fast, when the vehicle started loose, it's very difficult to actually bring it back, right? Bring it back. But understeer is known to be bit safer, right? Bit safer. So, but this is not only happen because of the vehicle's steering, right? There are other instances it could actually happen. One very good example is how the vehicle's power is delivered, right? Power is, if the power is delivered to the front wheels, those vehicles are tend to have understeer, right? If the vehicle's power is delivered to the rear wheels, right, then they can have tendency to have oversteer, right? Oversteer, because they can actually lose the rear grip very soon. But in the front wheels, they have a different problem, which we discussed earlier as well, which is known as Stokes steer, right? Torque steer means, as I told you in the transmission module, because the transmission is to one side of the steering, right? One side of the steering, right? So this ended up creating sort of a torque effect. So the shaft, if you look at the image over here, right? The output shaft length. So over here, output shaft length on your the left drive shaft is actually smaller than the length of the right drive shaft, right? So this is similar to this effect. So you have too much torque effect actually going into one side, right? One side is getting too much torque. So to fix this, we have to use a similar arrangement to this, the one shown in the top image. So the drive shaft lengths are equal, but instead of having these drive shaft, there's an additional shaft, right? Additional shaft to fix this, right? Additional shaft in the middle, right? So this torsion, right? Torsional effect actually increase with the length, right? With the length. So you can see when the length is actually increasing, the torsion also increasing, right? So these torsional changes happen with the length and the radius of the shaft. So that's why this actually has a thicker shaft in one side and thinner shaft in the other side. The longer shaft actually have a thick or higher diameter, right? In this case, even though still have different diameters, you can see it's clearly smaller than the diameter of the previous shaft. So that's actually been designed and built to actually avoid this Stokes steer, right? To avoid this Stokes steer. Yeah. So steering system, yeah, we have the steering wheel where we actually can have the grip and everything. So the steering wheel actually have to be designed ergonomically. Ergonomically means, you know what ergonomically means, right? Sorry. Ergonomically means, so the driver or the passengers, it will be very easy for them to handle and everything, right? So that's a science. It's science sort of, yeah, science behind the human, how the human is actually interacting with the machines. So we have this steering shaft and the steering column are very important components, because these are actually safety components. If we come back, so you can see over here, right? There are like universal joints or hook joints are there, right? One, two, three hook joints are there. But most of the time, this much of hook joints are not necessary for this steering system. But anyway, they put a lot of hook joints. And the reason for this is this steering system or the steering is designed to collapse in sort of accident. So in sort of an accident, these hook joints allow this front rack part to move, rack or the steering rack to move without moving the steering wheel and the column and everything. So that provides the safety cell for the driver, right? Safety cell for the driver. So this is the rack and bearing steering, and you can actually see this now very well. Wait. So this part, if we come here, right? So you have the front suspension or this hydraulic damper coming up, and it's connecting to the knuckle. So this section over here, this thicker part is actually known as the knuckle, steering knuckle, right? From knuckle, there's extended part, right? There's an extended part which comes and connect with the power steering or the steering rack, in this case, the steering rack. Okay. Yeah, so steering wheel diagnostic. One important thing is steering wheel actually has a small play. That play is necessary because the vehicle, when the vehicle is actually traveling, right, the vehicle, the wheel is hitting with the potholes and everything. In order for that not to travel back to the driver itself, this play is there, but that play should be around 33 millimeters, so 1.5 inches. If it is more than that, right, if it is more than that, it could end up being very unsafe. So those things actually have to be fixed, so that play can be coming out of any of the steering components. If it is more than that, usually the steering ball joints and the tie rods and those components are worn out. Those need to be actually replaced, right? So, and if there's like a hard steering, right, if the steering if it is a power steered vehicle and if it is very hard to steer, usually the usual cases are power steering fluid, less power steering, less fuel, less power steering fluid, and pump belt broken or slipping, right? But belt slipping usually comes with the squeezing noise, but it's not all the time, right? It's not all the time. So for maintenance, there's like a rule of thumb or something like that. So every time when there's maintenance comes in hand, we usually always consider the most possible thing and the least catastrophic or the least worrying thing. So for example, if there's for in this case hard steering, the first thing you should come it should come to your mind, as if you are doing automobile or maintaining a vehicle, the first thing should come into your mind is, okay, should be the engine should be having less power steering fluid, right? That's the first thing you should that should come into your mind. Not you should not think about, okay, my power steering rack is completely worn out or something. That's very bad practice. We always, there's like a step by step way to approach these things. We start with the most possible and the most obvious thing, and from there onwards we move down, right, to the least obvious thing or the least possible thing to actually happen. So steering system noise, yeah, bell squeal means while screeching sound produced by the worn out bell. That's a common thing. Power steering pump noise is usually a loud whine that only occurs when the steering wheel is turned, right? So if there's a power steering pump noise is coming, it's actually coming like a sort of like a whining noise, and this comes when you turn, right? When you turn the vehicle, this usually comes with low fluid as well. So with this, we move to the directional stability. Directional stability means this how the steering, suspension, and the wheels are actually interrelated, right? How these things are interrelated. So directional stability is the how vehicle is stable at all directions, right? When the vehicle is traveling, whatever the direction you ask the vehicle to travel on that way, the vehicle should be actually stable. So in order to achieve that, vehicle has to be aligned, right? Vehicle has to be aligned. So align means, right, the wheel track. the front and rear wheel tracks, right? They should be parallel and equal. So that means the distance between the front left and rear right, and the distance between the front right and the rear left, so these diagonal lengths should be same. So if these diagonal lengths are not equal, then the vehicle have alignment problem. So when this alignment problem comes, the vehicle, we call it as crab walk, right? Vehicle is actually traveling to or moving to a direction. The steering is, you always have to keep the steering in a one angle. You always have to correct it, right? Vehicle is trying to pull it to one side, right? This is we always have to fix this. So in order to achieve this, right, in order to achieve this and to keep the steering system and everything very well pointed, we have something called caster, toe, and camber. I know you guys have learned these things again, right? So we'll start with the caster angle. Caster angle means, right? So this part over here, right? This ash color section is the uh, this sort of like a flower pot sort of shape. This is actually known as the steering knuckle, right? So steering knuckle is not always perpendicular to the ground. It could be in an angle like this or that, right? These angles are important, right? These angles are important because this angle helps the vehicle to bring the steering back to front, right? Back again. So steering will come back if you release your steering, right? If you release your steering wheel, the vehicle will come back to straight position. So that actually comes with generated by this caster, right? So caster angle. So I'm not actually going to go through this very detailed because it's very complicated, right? So how the caster angle is coming, how the toe is coming, and everything, right? Camber is another important thing. So the camber always ensure that the vehicle maximum amount of the tire, right? Maximum amount of the tire is always touching the ground. That's what actually the camber is used to, right? Camber is used to. So next we move to toe in and toe out, right? Toe in and toe out, make sure that vehicle is always travel in a straight line, right? Straight line. Also, it helps to deliver that we discussed about having, sorry, steering sensitivity. In the steering sensitivity, we discussed about, before steering sensitivity, we discussed about the, sorry, before steering sensitivity, we discussed about having this what you call this yeah, before steering sensitivity discussed about having this true and Ackermann angles, true Ackermann, less Ackermann, more Ackermann angles. So these also comes into play with these Ackermann angles, right? So basic idea of the toe is to keep the vehicle straight at all times, right? And camber ensures that vehicles tires are contacting patch, or the contact patch is always the maximum amount of contact patch is achieved. And the caster always make sure the steering comes back to front position. So these are the three functions that actually provide. But if we make them wrong, if these adjustments were wrong, right, vehicle alignment could go wrong, right? Vehicle alignment will come up wrong and the directional stability will be lost. In addition to that, uneven tire wear or too much tire wear, these sort of issues will be actually generated. So next we'll move into the wheel part. So wheel, in this section we actually discuss about the tire actually. So tire actually tire is a very complicated component, right? Even though it's just a piece of rubber, it's one of the most complicated components in a vehicle, right? So there's a special subject actually called tire dynamic, which you guys are not going to learn. It's very advanced subject called tire dynamics, right? The reason is tire, when we are actually driving, tire actually change its shape. These changes in the shape affect the performance of a vehicle, right? Affect the performance of a vehicle. So the tires that we are using nowadays are actually called as pneumatic tires, right? Pneumatic tires, because we put air into them to get this lightweightness and the or the dampness, right? So when we come to this tire dynamics part, right? Tire dynamics part, the most important thing is that how well tire is supporting the weight of the vehicle, right? Weight of the vehicle. So there was like two types of tires used. There was two types of tires used. We had something called bias ply and a radial ply, right? Bias ply and the radial ply. So the problem with this bias ply and the radial ply, right? So okay, so I didn't put bias ply and radial ply. I just I had to put that. Sorry. Yeah, bias ply and radial ply tires are there. So if we let me just yeah, so this, even though tire seems to be just a rubber tire, it's not exactly like that. It's actually has a steel or a fabric interior or fabric ribs inside. So these ribs actually supports the weight, right? Supports the weight and its work against the deflection. So as shown here, right? As shown here, when the vehicle is actually taking a turn, oh right, when it's actually taking a turn, the vehicle is trying to move to the opposite direction of the turn. The vehicle's weight of the vehicle is trying to move to the opposite direction of the vehicle, right? So the tire has to resist it. Tire has to resist that, and it should not actually lose this contact patch, right? It's not lose this stack patch. Now you can see over here the contact patch is larger, right? Then this contact patch is reduced with the cornering, right? With the cornering. But if you come here, the tire still has almost the same contact patch, even though the cornering effect is coming up. So this is why the radial tires are important, right? This is why the radial tires are important. So these dynamic changes of the tire affect the vehicle performance, the braking, the handling, everything actually depends on this, because this is the only point vehicle is actually touching the ground. Yeah, so this is important, right? This part is very important. Anyway, so vehicles, if we come like uh yeah, so now because of that we actually have these radial ply tires which are not deflecting that much. So the tire wall, the size of the tire, everything actually is affecting this, is actually affecting this. But how the internal structure is aligned, right? How these internal ribs or the steel mesh or the wool weft or the fabric mesh, its alignment way is very important for these type of tires, performance of the tires. So tires, actually there are different types of tires. These threads, the tire threads, based on the type of based on the type of use that we are going to expect, the tire threads has to be different. One important thing you all have to remember is tire threads are not needed, right? So it's like this. So Earlier I told you that maximum contact patch is necessary, but later I can't say, I am saying the threads are necessary, right? Because when you put threads, you are actively actually removing certain amount of rubber material. That's a problem, right? You should not remove rubber, right? If you remove rubber, that means you are losing the contact area, right? But you might have seen the tire, most tires actually have these threads. The reason is the tires for a vehicle, for a passenger vehicle, we can't change the tire based on the environmental conditions, right? So the vehicle tire should be able to go on the mud, tire, or in the tarmac or in the gravel and everything. So, and at that case, right, at that particular case, these threads are important, right? These threads are important, right? Okay, so we'll come to this one, right? We'll start from this one. So this is a all season tire that it can be used in the winter, or if it is like a very dry season and everything, in the rainy season, everything, this can be used, right? So these sort of tires, right, these sort of tires are important. These sort of tires, these threads, right, these threads are designed, right, these threads are designed so in any condition, right, in any condition, tire has the maximum contact point. So it's like this. If it is in the rainy season, right, these threads are assisting the tire to remove the water, right, remove the water, right? So when the wheel is actually rotating, what actually happens is the water traps in these channels or these threads, right? Then because of the direction of this thread, the water actually push outwards from the tire, right, from the tire. So there will not be any water in the contact patch, right? So that's why you actually see sort of like a path when a vehicle travel on the rain, right? That's actually generated by these threads. Okay, so now if we look at here, right, in number one, these all-terrain tires, these have these grooves because they are designed to actually go off-road sort of. In such case, right, in such case, the ground is probably soft, right? Ground is soft, so you need to have more contact area. So in such cases, these grooves also can allow more material to come inside. The ground material can actually come inside and increase the contact, right? So that's important. Same thing happened to the all season tire if you put it into the mud, right? Any of these tires, right? But if we remove these all these threads, right, that means there's no threads. If you look at a race car, they don't actually have threads. Unless they are having a rain or something, they don't have threads. They have a smooth surface, right? They have a smooth surface. The reason is, if you have threads, that actually reduce the contact patch when you are going on the tarmac or the ground, hard ground. At hard ground or like a carpet road or something, these threads are not that useful. Not that useful unless it's there's water or mud or something, right? That's why race cars don't actually have threads, right? Because that's not the optimal solution. Optimum solution is not to have anything, any threads. But if we have threads, right? If we don't have threads, then we have the ground, right? And if the rain started to fall, right, if the rain started to fall, rain comes and it generate a plane, a small gap between the wheel and the ground. So this is actually, this phenomenon is actually known as aquaplane, right? Aquaplaning. So aquaplaning means there will be water trapped in between the tire and the ground, right, in between the tire and the ground. So right, so this is not ideal for a normal passenger vehicle, right? So that's why we have these threads. But also, even with the threads actually have a maximum limit that they can take over the water, right? So for these wheels at a typical particular speed, the maximum is around 30 to 80 liters, right? 30 to 80 liters per minute, right? 30 to 80 liters per minute for a certain amount of RPM, right? So if the rainfall is higher than that, again you will actually have aquaplaning, because the tires cannot withstand that much of water. This is actually happening. One place this always happens is the Southern Expressway. So if you have seen, if you have been in the Southern Expressway when there's like a very heavy rain, you can actually see aquaplaning, and you can't go fast. You can't go fast. Started to twitch, right? Started to lose the contact. Okay, now we come back to these tire. How you going to read the tires, right? So important, there's so many numbers and details and everything. The most important numbers are these things, right? Those are the most important parts, right? In addition to that, it actually have how much of pressure you should put, right? How much of pressure you should put, what is the maximum thread wear. So thread wear means how much until when you should actually use. So how much of thread should be limited. There's a thread gauge, which I forgot to put a picture of that. I will show it next day. So thread gauge is there. From the thread gauge, it should have this much of thread, right? Then this thread means this is 4 plies, the tire composition and the material used. This actually gives an idea how much of plies are there. So if it is like 4 plies, that means a car tire. If it is like 6 or 8 plies, means it's sort of like a van tire, right? Higher the number of plies, the higher it can actually, higher it can take load. The ply means the internal structure, internal, that the one I actually show you. Wait, this one. This is actually the ply, right? So sorry, right? So higher the number of plies, the stronger the tire is, right? So here it's given the maximum load. In addition to this, there's a date coding somewhere. It's not mentioned here, right? So now if we come to this important part, right? Important part is the tire detail. So it says P215 slash 65R15 95H, right? M plus S. So M plus S means the condition of the whether it's a snowy condition and all. So 95H means the load index and the speed symbol. So how much of speed this can mention and how much is the load index is there. So the important part is this one. So P means passenger, right? If we move to here, right? So that part, right? So P means passenger vehicle, LT means light truck, ST means special trailer, T means temporary. Temporary means the space saver spare wheels, right? And the three-digit number, this one. This one over here, right? That means how much of the width of the tire. Width of the tire means this is the width of the tire, right? That's 215 means it's in millimeters, right? That's in millimeters. So this is millimeters, how much of the tire width, right? Then this 65, right? 65 means aspect ratio. I'll come back to the aspect ratio list next, right? Before that, we go to the R part. R means what type of tire is this? So I told you there's bias ply and radial ply, right? So if it is a bias ply, this comes like B, right? If it is a radial ply, it comes like R, right? 15 means how much is the rim diameter, right? Rim diameter, that's in inches. right? That's in inches. It's not mentioned here, right? Uh, yeah. So this 15 means how much is the diameter of the wheel. So this is the rim diameter, right? But this R does not mean rim, right? R means radius. Now we come back to this 65. 65 means the aspect ratio, right? Aspect ratio is very easy to explain from here, right? So tire width is the first number, then slash, then you have the aspect ratio, right? Aspect ratio, and you have the rim diameter. So how it comes is aspect ratio is the section height. Section height means the side wall height, right? Side wall height of the wheel, right, is divided by tire width. Tire width, right? Tire width. Then it's multiplied by 100. That's actually called as the aspect ratio. So by using these two codes, we should be able to say how much is the tire side wall is. So the reason for having this aspect ratio is for the same width, different tire heights are there, right? So if you need to know the total height of the tire, you actually have to find the section height and get the rim diameter, bring them up to the same unit, because rim diameter is in inches, section height is in the millimeters. So bring them up to a single unit and add them. But when you are adding, you have to add twice the section height, because you only get one section height and one rim diameter. So there's another section height here, right? By doing so, you can actually find out what's the tire size. So if you know the tire height, right? So if you know the tire height, you can find out how much of the half of the tire height is. So if you know half of the tire height, you know how to actually find the right height of the vehicle, right? If you change the tire, how much of vehicle is going to lose its height. That sort of thing you can actually find with these equations. Okay. So yeah, that's it actually. That's all you guys need to know about this uh, suspension and sorry, about the steering. I added few reading material and videos for you guys to watch and get more details about them, and I hope you might be you will be seeing them and get more idea about them. Next we'll be discussing about the suspension system.